Myself, Govind Jaiswal, Government Navin College, South, MSc Physics. In this seminar topic, I will discuss about the counter digital circuit. Counter. When we hear counter, the commonly first question in our mind: what is counter? How he looks like, and what it does. Then I will discuss digital counter overview and introduction. Counter is just a counting machine such as a system clocks, timer, stopwatch, weighing machine, or any other type of the counting machine you see. It is just a sequential circuit for counting purpose, and if our number is 1, then the next time it will be count 2, 3, 4, 5, and so on. Means, and if you want 0 to counting 9, then 0, 1, 2, 3, 4, 5, 6, 7, and 10. And if you want counting counting 0 to 200, then we must count 0 to 200 times. Means there also may be count from the any preceding point to any नेक्स्ट टाइम और लास्ट टाइम. इट ऑल डिपेंडिंग अपॉन योर डिजाइन. ठीक है, मतलब काउंटर को काउंटिंग करने के लिए कि हम डिजाइन खुद से कर सकते हैं इन जस्ट इन योर माइंड. रिकॉल इट एसिंक्रोनस का recall it asynchronous counter or ripple counter. If our flip-flops are in a parallel way, then it just called as synchronous counter. This make classification of the counter. In we need a classification of counter. Then types of counter. Ripple counter is asynchronous counter, and the asynchronous counter is a clocked counter. And the counting, it will be depend and can classify the further depending upon the counting way. मीन्स हम उसको किस डायरेक्शन से उसको काउंट कर सकते हैं, अप टू डाउन आर डाउन टू अप. मीन्स इफ यू वांट टू काउंटिंग 0 1 2 3 4 5 and so on, means this is a up to up counter. And if our counter is counting according to 9 to 0, means 9 8 उसके रिवर्स में है ना 9 8 7 and so on. We know that the counter is just a flip-flop and our collection of flip-flop, and we know the flip-flop is a storage of memory and also use be frequency division. And because of the flip-flops negative triggered, classification of the counter is depending upon the counting way, like up counter, down counter, and a third is a up down counter. It is a combination of the down counter and up counter. This is our 2-bit JK flip-flop. Initially, if we take Q0 is a 0 initially, Q0 0 initially, then the 0 pulse falling down for Q1. So change the Q1 is a complementary of Q0. Then it is a high value, and the having if you Q0 is equal to 1, then the Q1 is a Q1 get a 0, and this process will be similarly. So we can plot the frequency division of the clock as like the Fourier frequency of the counter. This is a clock, and this is 0 and up to down high is 0 to 1, and that's all. So our Q0 is when the falling of clock or we take the name this TC. The TC means time frequency of the clock. This is a 1, this is a 0, or when the falling of the negatively is called 1, and this again 0, then it's 1 and 0 and 1. Then we can plot this edge, they call it edge. Then Q0 plot TC is equal to when the falling negatively, then it just 0, and the falling down, then it will become high. So it high and 1, and again when it become low, Q0 is a high. Yeah, 0 1 0 and so on, such that the Q1 is when the it depend upon the Q0 is lowing or high, then the Q1 depending upon the Q0 is, and Q0 is just falling down in a here, here is a, just 1 2 sorry 0 1 and 2. Then here the Q1 is high, then it will be so 1, and this process will be continued. And they got this type of a frequency division where clock is 0, then when it up to high, then first rounding of the clock is 1. For Q0, when the 0 is changed into 1, then it will be 0 and change the 1. And when our second traveling 2, then it will be become 0. फिर again 3 1 and so on. Our clock frequency, if our clock frequency is a TC and Q0 has a T0 and T1 equal is frequency time period T1, sorry 1, then we can now see that T0, the T0 is the T0 is equal to T0 equal to 2 TC, and T1 is equal to 2 T1. T0 means that if you derive the formula, truth table of the JK flip-flop with 2-bit asynchronous counter is a, that I will plot that counting, and this is clock, and this is Q0 and QB Q1. Okay, if a clock is a 0 0 sorry 1 1 1, then Q0 is initially 0, so the Q1 gets 0, and second times if Q0 is 0, then Q1 is 1, and when the it will be Q0 will be 1, then Q1 will 0, and 4 times Q0 1, then Q1 equal to 1. Okay, if have a number of flip-flop, then the frequency region of the any counters is a 2 power p. Means that if our we have a 2 flip-flop, then 2, and we can put p equal to 2, then we get 2 power 2 equal to 4. Means that our we have 2 flip-flop, then our frequency division has a 4. If p we can put p equal to 3 or 4, 3 or 4, then 2 power 3 means 8 frequency division, 2 power 4, 2 power 4 means कितने हो जाएंगे वहाँ से 16 frequency division. The types of electronic counter is a synchronous counter and asynchronous counter, a ripple counter. up down तो हो गया. Then synchronous counter and asynchronous counter have a great difference according to their parameter. Synchronous counter clock input is simultaneous, and synchronous counter has a not all flip-flops receive clock signals simultaneously. The maximum frequency of the operation, the asynchronous counter has a low frequency, and the synchronous counter has a large frequency. The asynchronous ripple counter 2-bit, 3-bit, and 4-bit way. This is our 3-bit. This is a 3-bit ripple counter. Have a 4 flip clocks. Okay, 4 flip flops. The trailing of the clock T is a negative trailing, and it comes to become. Let's see asynchronous ripple counter in a 2-bit, 3-bit, 4-bit, and wait. This is a 4-bit ripple counter where the we use 4 flip flops, and this is the diagram of the ripple counter. Initially, when trailing 0 0 0, then our all Q are 0. In the second stage, we can see the Q0 becomes 0, Q1 0, and in 5th times Q1 1 and Q0 1, and 6th time The Q1 becomes 1,